Backtracking decisions within a design process, a way of enhancing the designer's thought process and creativity. This research project deals with design history. We examine the decisions taken by the architectural designer and how it is possible to formalize the sequences of these decisions. There are two variants of history models, linear and branching. In the linear model, on the left, history is maintained as a simple ordered list. Decisions that do not belong to this list are deleted. Commercial CAD packages frequently resort to this model to preserve the design history. It seems that valuable data is deleted during the undo process. Afterwards, the designer may be wondering, what is it I did a moment, an hour ago that was kind of interesting? If new operations interceded between the undo and redo steps, the finding of the answer will depend solely on the user's memory. The system will provide no help whatsoever. In the branching model, on the right, all decisions previously taken are preserved in the history, even when they are not part of the active path being explored. So the system records several alternative configurations of the architectural object. We believe that design, as a process of creating an object, cannot be represented by means of a linear timeline. We start from the premise that the nonlinear model, although far more complex, tallies with the creative process. It seems to us that every step of the design process is valuable because previously discarded solutions may prove to be useful later on. The branching model may be seen as a graph structure composed of multiple branches connecting the alternative decisions. The designer creates and explores several alternate pathways while making tentative moves towards an architectural solution. When he is unsatisfied with the results of an experiment or comes to a dead end, he may backtrack and explore other branches of the graph in order to orient the concept towards different directions. Our goal is to implement tools that could enable the designer to experiment with nonlinear processes. We wish to provide digital tools that could help him broaden his image repository, go beyond the limitations inherent in short-term memory, and enhance his thought process, creativity, and critical thinking. We believe that working with parametric objects is a suitable approach to examine the structure of an ideation process. It allows us to formalize a solution space which can be seen as a territory. What is of interest to us is to examine the designer's movement within this territory, to what extent these movements can constitute a clear picture within the user's mind, and how it would be possible to communicate the exploratory process to an interlocutor. We implemented a digital environment in order to be able to conduct experiments. We made use of the commercial CAD package Autodesk Maya. We opt for this package for two reasons. Maya Embedded Language MEL enables us to quickly implement and test graphical user interfaces, and it enables us to use the object-oriented programming language Python to communicate with the geometric modeling kernel. Obviously, parametric objects are more suited when the element being designed is an architectural object rather than a whole building. At present, we work on a case study dealing with staircases. The selection of this architectural element is based on two advantages. On the one hand, designing a staircase requires a wide set of interrelated decisions. The choices made at the beginning of the design process have an impact on the parameters that will be relevant in the subsequent phases of the process. On the other hand, there exist multiple types of staircases. Their configurations range from very simple to rather complicated ones. So the mandate of the digital environment is to enable the user to explore a vast gamut of scenarios so as to determine which types of staircase would fit in the building he is designing. Here is the graphical user interface. First, let's examine the main menu. The Design Session menu enables us to export the current scenario towards Maya, erase the current model, and start again, or quit the digital environment. The Scenario menu enables us to save the current scenario or to access previously recorded scenarios. The Graph menu asks the system to display an image of the current branch within the graph or to display an image of the current position within the branch so as to enable the user to get his bearings. Let's say that we want to design monumental stone stairs. These stairs would give access to the first floor of the building, situated at 1.3 meters from the ground. Within the first node of the graph, we are asked to choose between 1, 2, or 3 flights. We choose 1. Within the second node, we have to select a configuration, straight or curved. We choose straight. This option brings us to a different kind of node. The first two nodes we explored enabled us to take basic decisions regarding the type of staircase. By pushing blue buttons, we were able to move within the graph. This node is of a different kind. It enables the user to tweak the architectural solution by modifying the values of groups of parameters. Yellow buttons enable us to move backward and forward within this node. The system records and stocks the result of the designer's decisions by means of lists without overloading the computer's memory. So the sequences of decisions are made available for later use. In short, the system enables backward and forward movements within a given node as well as within the branching graph. At the beginning of the process, all values are assigned by default. As we can see, the 3D model represents the simplest configuration of staircase. The user modifies the values of parameters by means of sliders or radio buttons and is able to access the resulting configurations. First, we increase the width of the stairs to 2 meters. Since the landing should be situated only half a story higher, we lower step number from 14 to 7. A message warns us that the step's height is over 19 centimeters. We decrease the global height to 1.5 meters. Still too high. Now to 1.3 meters. We decrease the depth of the stairs to 1.6 meters. No, that doesn't seem right. We choose 2.2 meters. We wish to put a wall on the left side and to increase the width some more. We will be able to move backward and forward within this sequence of decisions later on, but for now we are satisfied, so we proceed with the exploration. The next node enables us to move within the graph. We are asked to choose the material of the steps, stone, wood, or metal. We choose stone and proceed. The next node enables us to tweak the configuration by taking decisions regarding the details of stone steps. We wish to add an arch below the stairs. We can choose a squared riser or a rounded one. We wish to widen the first steps. We choose 3 steps. No, that's too much. We opt for only 2 steps. We verify if we would like rounded steps. And finally, we opt for parallelepipeded ones. We change our mind and opt for a squared riser. Now, we take decisions regarding the banister. We choose among without banister, stone banister, and metallic banister. We choose stone banister. We wish to visualize open-work banister. We tweak the width and position of the components. We explore both type 1 and 2. Again, we make adjustments. Now let's see how it would look with a balustrade. We make adjustments and want to verify if it would be better with the second type of baluster. We make adjustments No, we wish to go back to a previous scenario that seemed more elegant. We go backward and backward again and access an open work banister. And proceed. We change our mind regarding the details of the steps. We go back to the node dealing with those details and backtrack in order to get rounded steps with a rounded riser. And proceed. We changed our mind regarding the wall. We go back to the corresponding node and backtrack to remove it. We record the current scenario and name it Monumental Stairs, Wednesday 8. We wish to browse among the scenarios we explored earlier this week. We choose Monday 6 and we can access previous configurations if we want to reenact the design process that brought us to this scenario. Clearly, the user is not restricted to the territory defined by the developer. After developing an interesting scenario, the user is able to access the functionalities available in Maya's graphical user interface and modify the shape of the entity. By means of the outliner, he can modify the geometry of any given component. In doing so, he pursues the design process, giving free rein to his creativity.